which are necessary for this flange coupling. Okay, so if you look over the bill of material, so it has six parts here. Flange number one, flange number two, third one is a shaft, fourth one is a taper key, fifth one is hexagonal bolt, and the sixth one is hexagonal nut. Okay, right? So first I'll go for flange one. So if you look over the flange one, so now the dimensions. So now this flange coupling is designed for a shaft of 50 diameter. Okay? For a shaft of 50 diameter. Now what I'll do, so I will go for creation of first part. Now if you consider axis here, so if you look out, all dimensions are of a circular. Okay, all dimensions of an circular. Okay? That means to make a model by using shaft option, so you need to draw only this much of portion, only this much of portion. So now if you are using shaft, so it's going to rotate at the 360-degree. Okay, so the thing is that you need to go for shaft. So let us notify dimensions 80, 46, 5. Okay, then 50 it is here. Okay, then it has a 53. 53.4 is for keyway cutting. Let us say keyway cutting after completion of the flange. Okay, next PC 150 is here, outer diameter 216 is here. Okay, now flange thickness is 25 so now these dimensions will become 11 Okay, okay, now go for start mechanical part design. So now I'll go for shaft here. Now for selection of sketch, I'll select this front plane. Okay. So first you draw one axis, a reference axis. Okay. So use constraints. For selection, you go for multiple. No, I'll draw first rough surface here. That is what rough profile. Now you go for dimensions. First you go for outer dimension. It is how much 216 divided by 2. Okay. 216 divided by 2. Now shaft diameter, it is to be 25. Now overall length, it is 80 mm. Okay. Now this step portion is of 75. Okay. This is 75 divided by 2. Next, this portion is 50. Now this has to be 216 divided by 2. Now this is what thickness of and this is 25 mm. Now this has to be 46. Now let us look out. Now this portion has to be of 8 mm. Now this extension from this portion to this portion is of 5 mm. You need to go for a chamfer. We'll go for chamfer option today. Okay, we'll learn chamfer option today. So 360. Okay. This is completed flange. So once you got the flange, you need to drill 4 holes here as well as you need to create a keyway. Okay? So now to create a keyway, I'll go for pad option. Okay. Now I'll select this YZ plane. Okay. So make model as a wireframe. So now taper is given here. Taper is 1 in 100. That means if we have an 53.4 mm at this top corner, now here it has to be 52.6 mm. Okay, that means for every slope. So now if we have a slope of 1 in 100 means, so if you have a length of 100, then the increment or decrement has to be 1 mm. Okay, so let us I'll draw the line here. Okay. Let us go for dimensions. This is 2053.4 means going for degree. This is 53.4 minus 25. Okay. Now similarly here, 53.4 minus 0.8 minus 25. Now just complete the profile to cut the keyway. exit. Okay. Now width, how much you need to cut? You need to cut 16 width here. Okay. So here 16 Go for mirror direction, 8 on each side. Okay. Preview. Okay. So we need to take some extra amount here. So that has to pass out from the component. Okay. Now we have a gap. Okay. So that is why the material has been not removed there. The material has been removed. So again, I'll go for pocket here. I will select this surface. Okay. What I'll do, I'll place one hole here. First, I'll place one hole. Okay. So what is the hole diameter? Hole diameter is 16 4 holes at a pitch circle diameter of 150. They have been placed equal distance, equispaced. Go for 75 here. Okay. Sorry. This is what 75 minus 8. Okay. So we have placing dimensions with respect to quadrant point. Actually, you need to specify with the center point. Now this has to be 0. This has to be 0. Otherwise, you can draw in construction line here. Sorry, construction circle. That is what pitch circle diameter. Okay. Then you can draw a circle on its quadrant point. Okay. That is also okay. Now, how much depth you want to cut? You want to cut for entire 25 thickness. That is what total flange length. Let us go for 26 Okay. So now as you're performing a cut operation here, you can draw at a time 4 holes. Okay. Instead of drawing one hole, you can draw at a time 4 holes. That is what here you can draw at a time 4 circles is going to make a cut. Okay. Otherwise, you actual according to manufacturing process, you need to go for a whole operation that has to be carried by drilling. Okay. Right. Now I'll go for a pattern here. Now I'll first select this patch. I'll go for pattern. That is what circular. Circular. So already I've selected element. Okay. So now I'll select reference as hollow portion. Okay. Now how many object you want to place? You want to place including original as a 4 here, but for instances you go for only 3. Now including, okay, distance between each, okay, is 90°. Right? Okay. 1, 2, 3. So you need one more. Let us edit here. Definitions 4. Okay. preview, say okay. 1, 2, 3, 4. Let us look out in side view. Now we have four holes. Next, you have a chamfer on this edge. Okay. So let us go for dresser feature here. Okay. So now this is chamfer. Okay. So distance is 2 mm. Angle is 45 degree. Okay. So you just select this edge. Okay. Preview. Say okay. This is what chamfer. In chamfer, you can go for length angle. Okay. Or length. You can go for length 1 angle or length. Okay. Okay. Next, for second part, now this is what a flange one. I'll just save it. So what I'll do, I'll go for save as the same file as a save as. I'll make this as an flange 2. Okay. I'll just delete this chamfer. Okay. I'll keep these patterns as it is. Okay. Now the only thing is I want to change the shaft. Sorry, the flange profile here. Flange profile. What is the flange profile for second here? Now it has a cutout of 6 mm. Okay, it has a cutout of 6 mm. Rest of the dimensions are same: 75, 216, 150, 53.4. Everything is same. Just observe. Now we'll take line from this endpoint. Just drop line here. Now I'll go for measuring dimensions. Now this has to be 6 mm. Now go for trim out unwanted portion. Okay. Now this is what a flange do. Just to save it. You got two parts. So next one is flange 1 is over, flange 2 is over. Now you need to go for a shaft here. Okay. Shaft. Now it has a diameter of 50 mm. It has a diameter of 50 mm. Now the thing is that you can do shaft by using a revolved protrusion. That is what we call in CAD as an shaft. Okay. You can call in a CAD as an shaft. Okay. So otherwise, you can go for a pad option. That is also possible. You just draw in circle and you can extrude it. Okay. So now what I'll do, I'll go for first as a pad. Now in this case, I'll select this Z-X plane. That is what side view for drawing the circle. Now let's it. I'll go on one side. I'll go on one side. So minimum length you need of this 80 mm. I'll go for 100 mm protrusion here. On this side you have a chamfer. You can just look at it. Chamfer is 2 into 45. Click on this chamfer. Okay. Select this edge. Provide dimensions is about 2 mm. Okay. Chamfer. Now you need to cut out a keyway here. You need to cut out keyway. Keyway is 90 mm length. Okay. So what is the depth? Depth is of 44 mm. That means from this bottom quadrant point it has to be 44 mm. Now just look out. I'll go for pocket here. I'll select this YZ plane or XY plane. You can select any one. You just fit. What I'll do, just draw a rectangle here. Okay, a rectangle. Now keyway length has to be, sorry, I think we made a complex. Yes. Now first part is over. Okay, we'll go for sorry, we'll go for pocket. Okay. Now we'll select this XY plane. Now it has been rotated because of directions. Now I'll just draw a rectangle. I'll just draw a rectangle here. Okay. Now I'll measure the dimensions from this axis to this axis. Now this has to be what? 44 minus 25. Okay. Now the overall length from this to this has to be 90. This has to be 90. Now I will select this line and this edge. I will go for coincidence. Okay. Okay. Exit. Now this has to be mirror exchange. Now the distance is, what is the key width here? It is also 16 mm. 16 mm. Okay, I can go on only one side. Okay. 16 mm. Just go on. Once again, I'll go here, pocket, select this front view. Okay, for fit, draw a rectangle here. Dimensions. This is 44 minus 25. This overall length has to be 90 mm. Exit. Mirror. Total distance is 18 mm. Right? So what kV? I will say this as in a shaft. Now taper key, it is of 85 length. Taper is 1 in 100. One side height is at 10. Another side height will be 10 minus 0.85, that is a 9.15. Okay. Look for start. Again, I'll go for part design. I'll go for pad here. I'll select this front. Okay. Now I'll just draw one rectangle. What is the size? 85 by 10. So I'll draw furfur directly instead of going for rectangle and that's taking its taper. So now on this side is how much it has to be 10 mm. On this side it has to be 9.15 mm. And I'll join here. Exit sketch. Now mirror extent. So thickness is how much? It is 16 mm. Now this is what key. So last components are hexagonal bolt and nut. So dimension is it is a 16 mm. Okay, it is M16. Okay, bolt total length is 66 mm. Bolt head is 12 mm. Nut thickness is 14 mm. Let us go for last component. We'll go for pad. I will select this side view here. Now we need to draw polygon here. You need to draw polygon. So let's go for polygon. That is what hexagon here. So to draw an hexagon, you have two options here. So inscribed in a circle, circumscribed about a circle. Otherwise, you just draw a circle. Okay. You can place a hexagon by dividing option. So in this case, I have gone for direct hexagon. First you select all, edges, length as equal. Let us edit. Okay. Provide center point. In sketch tool, you provide the dimensions. Okay. It is 16, 0. Okay. Exit. Go for again pad and select side. Sketch side view. Hexagon. Provide center point. Okay. Dimension 16, orientation is 0. Somewhere I will say, okay. You just mirror it. Thickness is 12 mm. Mirror is taken on both sides. 6. Again, you go for pad. You click on this hexagon surface for sketch. Now you just draw one circle here with reference to origin. And it says 8 mm. For hexagon, we made a mistake. Let us check it. Let it be. Lower length is 40, 66. Okay. Now I'll go for editing the hexagon shape here. Okay. Now these edges has to be 16 mm. Okay. Let us check. Put a circle. Go for measuring radius here. Okay. It's showing 16. Okay. But actually length has to come 16 here. When you measure the distance from this distance across corners, so this has to be 32 based on the relations. Okay. Based on the relations. So as I said, if you have two options to draw an hexagon, then one is what drawing the hexagon circumscribed about a circle. Another one is inscribed in a circle. So let us go for drawing the circle. Hexagon in inscribed radius is how much? It is 2D. It means 16. Okay. Now I'll go for hexagon. I'll take here center point. Okay. And just provide angle. Now this is what circumscribed. Okay, now this has to be inscribed. This has to be inscribed. Okay, so you need to go for some editing options. Okay. Let's go for selection of this point and this point. Now this has to be on. It has to connect. It has to connect here. Okay. So here also it has to connect. So we need to check out. Otherwise, you follow the angle method to draw an hexagon. Now this is what hexagon bolt. Then I will close all these parts. So these parts are, I think one more part is left. That is what nut. Okay. Now you have done a bolt. You need to go for nut here. Now we'll save this as an bolt. Okay. I'll go for same file as save as a nut. Okay. Now I'll delete this part too. Okay, because we don't have an extruded body for the nut, that has to be hollow. Now edit this sketch. Okay, we'll discuss threading. Okay. We'll discuss threading at the time of some dresser features as well as feature based operations. Okay, so in feature based operations you are going to get some helical type cut. Okay, we'll discuss that one. So now this is what nut. So now I'll close. You have come across today two options. One is chamfer, another one is pattern. Okay. So in circular pattern, you have a lot of options. So if you want to practice those options, you just refer KR Gopalakrishna machine drawing book. You can just go for modeling as plate of a single plate clutch. Single plate clutch plate. If you go on for that one, so you can understand the other options. Okay. So if time persists, I will go for that one also. Okay. So today I'll close. We'll see tomorrow.